Welcome to my channel. I'm Zhang Jingxu. Let's look at problem 13 in chapter 21. Chapter 21 is about electric charge and electric field density. You can see we have this system, right? We have three charged particles are placed at the corner of this triangle. And the side length for triangle is given as 1.2 meter. And for each charged particle, the charge is given. Q1 is positive, Q2 negative, Q3 negative. And then we need to find the magnitude and direction for net force on each particles. So we can see, first one, we can find the electric force between two charges by using Coulomb's law, right? So Coulomb's law tells us the magnitude of the electric force. So in this way, we can get magnitude of electric force for the charge 1 and charge 2. So we write it as F12 equal to Q1, Q2 R squared. There, you can input known quantity inside, get answer there. So very similarly, we can find magnitude of electric charges for particle 1 and 3, and the magnitude of electric force between particles 2 and 3. Write it as there. Now, we need to find the magnitude and direction for the net force on charge 1. So, we look at the net force. So, first one, we do force analysis. We can see what force acting. First force is F12, agree? This is attractive force between charge 1 and charge 2. And also we have the attractive force F13. This is between charge 1 and charge 3. So now we can see this is angle 60 degree. This is another angle 60 degree. We need to project these two forces on X component and the Y component. Then we can consider its magnitude and direction, right? So now we can see we projected the F12 at X component as F12 cosine 60 degree, and because it's pointing to the negative X direction, so we add negative there. And also we look at the F13 projected on S component, it's positive, right? So it's just F13 cosine 60 degree. Similarly, we can look at the Y component. So F12 can project it to Y component as F12 sine 60 degree, and add the negative side. Similarly, we have negative side there as the F13 projected on Y component. So it is F13 sine 60 degree. We input known quantity inside, get answer there. Therefore, we can get the magnitude of this net force as 1 X component square plus Y component square and squared, and get answer there. And the angle as arctangent F1 component over F1 X component. So get answer there. Similarly, we look at the charge 2. So for charge 2, we have the attractive force between the charge 1 and charge 2, right? And also repulsive force between the charge 2 and charge 3. This is the X component. This is the Y component. So similarly, we can project the F2 on X component, and so get the net force X component. So net force X component is net force X component F2X equal to F12 X component plus F23 X component. Agree? So first one look like F12 X component. So projected in the X component, it becomes F12 cosine 60 degree. This is 60 degree. And also for the repulsive force between Q and 3, it is just horizontal pointing to left. So add the negative side there. And also at the Y component, we can see we need to project the F12 in Y component, F12 sine 60 degree plus 0, right? Input known quantity inside, we can get the net force for the X component F2, Y component F2, and in this equation, we get the magnitude of this F2 and the angle for F2. Similarly, we look at the charge 3. So for charge 3, we have the attractive force between the charge 1 and charge 3. So this is F13. And also repulsive force F23. Right? So this is X component, this is Y component. Now we can project this F13 in X component as negative F13 cosine 60 degree, because you can see it pointing to the negative side. This is a 60 degree. And F23 just pointing to the right X direction. And also we look at the Y component. We projected F13 to Y component as F13, sorry, this is F13 sine 60 degree plus 0. And then we can get the magnitude for the net force F3 in this equation, and also the angle of the F3 as arctangent F3y over F3x. Answer is there. Thank you.